painters don't make their own brushes. Builders are not making their own hammers and nails. API products for other developers is fundamentally different because you are selling a tool to someone who could actually just go and make that tool themselves.
Hey friends, this is Podcast Ruined by Software Engineer. On this episode, I get to talk to Sophia Willows, Head of Engineering at Rye. Rye is a one-stop shop API allowing its users to build e-commerces with any products on the internet. If you enjoy Podcast Ruined by Software Engineer, don't forget to hit the follow button on your podcast app so you don't miss out on the new episodes. And you can pick up podcast merch at perrytiu.com/shop. Enjoy the episode. Welcome back to another episode of Podcast Ruined by Software Engineer. I'm your host, Perry, and today with me is Sophia Willows, Head of Engineering at Rye. Sophia, how are you today?
I'm doing great. I'm really excited for this episode. Thanks for having me on, Perry.
It's absolutely our pleasure, my pleasure to have you on the show. I mean, to just paint the picture initially, who is Sophia and what is Rye?
Yeah, so I'm working as head of engineering at Rye, and I like to summarize this as my day-to-day job is to just make sure all the trains arrive on time. So we build this universal commerce API for developers. So we're similar to Stripe in that we build an API and that's our product, and we sell it to developers and they use it to add functionality to their apps. For most of our customers, their Rye integration, it's usually one of the most important parts of their business because it's the thing that makes them money. You integrate with Rye and we let you sell products from any store on the internet with just that one single Rye integration. So at Rye, we're a very engineering-led company. Engineering execution is crucially important. Things need to run smoothly. If we go down, people can't make any money, and their business is sort of in jeopardy. And my job is to make sure that everything's running smoothly, we're getting things out on time, things are not going offline, and we are shipping this, stable product that people can trust and depend on.
Target audience, if anything, as in like if you develop for developers, toughest crowd in the world, if anything. It's like trying to do like a stand-up comedy to like other stand-up comics, and it's like they already know some of the tricks, they already see what's coming forward, but they also really appreciate when the product is ran well and when it's like documented well. We're obviously going to dive into how you guys tackle that, of course, because it's a big project and everybody has a way of doing it, and I'm just glad that we get the chance to do that. But even before that, even just for context, Sophia yourself, like you've worked in engineering for many years in different roles. You've done a lot of building for sure, and you also done a lot of like project management, people management, and a lot of like operations, basically engineering ops. So my question to a lot of people getting the opportunity to live this kind of experience is, did you always want to go in tech? Did you always know you were going to go in tech? Or was it kind of like, oh, you just kind of slowly piece it together? So maybe to begin with, like, where did you grow up? But also, was it very techy around you? Did you have a lot of like people that were already doing software engineering, or was it slightly different?
Yeah, it's a great question. I grew up in New Zealand. And usually when people think of New Zealand, they're thinking of Auckland, which is our largest city. I grew up just like an hour south of that in a city called Hamilton. Was it very techy? No, not really. Today it's like a little different. We do have quite a few software and engineering companies setting up shop in Hamilton. We had a VC fund a few years back called Hillference that was particularly interested in the Waikato region, which is where Hamilton is situated, as sort of a source of entrepreneurship and tech talent. But growing up, didn't know any software engineers personally. I sort of fell into it because my original career plan of becoming an astronaut didn't quite pan out. Ran into some complexities there and had to figure out, okay, if I can't be an astronaut, what do I want to do? And my stepdad worked with computers, just like, kind of like a desk job, doing CAD drawings of like power plants. And he was personally very interested in computers, setting them up and playing with them. So I got into it through him. We installed DOS and stuff on a few computers. And that was kind of the moment where I was like, okay, well, this is fun. And, I like video games. Like working with these things is probably my best bet. And yeah, that was how I got into tech.
Was that kind of like lingo already around you in the sense of like people were able to talk a little bit about tech, or was it mostly just you've seen something for so long and then you just remember it from back then? They're like, oh, that was like AppleScript, or that was AutoCAD, or that was some other programming languages that you were looking at.
Yeah, that's a good question. I think like a number of years later is really when I did start to meet people who knew some kind of technological terms. So, I think my stepdad would have name dropped the program name AutoCAD or the Lisp variant that software uses for scripting, but I can't remember it. I was like super young. I was like 5 or something. But some years later, like 8, 9 years old, I got into this program called One Day School. And it was kind of like this program for gifted students. It was a little pretentious in retrospect. You had to take like an IQ test to get in and do all of these things. But once per week, every Thursday, you wouldn't go to your regular school. You would go to One Day School and be in this environment with all these other kids who had gone through the same sort of selection and filtering process. And there was one student there called Greg, and he was very into computers, like much more so than I was, a lot deeper in the stuff. And so he introduced me to like HTML and making like really basic web pages. And he also introduced me to the software called Game Maker, which I think is still around. And this was like my first real like programming experience, and like starting to learn like some of these terms, like what is a variable, what is a script, and butting my head up against the computer being dumb and my code being buggy and not working the way I wanted it to. So I think, yeah, like my first few years, like playing with computers, it was like very sort of unsophisticated. It was just like installing operating systems and installing software and browsing around the internet, playing video games. Half-Life was a favorite of mine. And then, yeah, some years later, I got into this one-day school program, intro to HTML and Game Maker, and that's where sort of my more formal, I guess, understanding of like computers began.
I absolutely love the spots and pieces of all these like geekiness pops out in the best way possible. Like I love when people talk about like the first time they work with XYZ games or XYZ tools or game makers or even any technology available back then. So I love these. And is it fair to say that your first machine was a Windows machine then, or what did that look like? What was your first computer that you get to play with?
Yeah, it was a Windows machine, and I was so excited when I finally got trusted to have like my own computer. I was sort of like stealing time from my stepdad's computer intermittently, but it was like this big compact desktop, like a big beige tower with I can't even remember what this style of mouse is called, but like it was the old one with like the ball, right? Like there was no like laser pointer. I think like children growing up today, like they'll never experience that joy of like taking your mouse apart and like cleaning all the gunk off of the little, the little ball because your mouse is like no longer tracking properly. I did that a lot. I remember like the operating system would have been XP, I think. I don't recall the exact specs, like I can't remember like what RAM or anything it had. But yeah, I had this big beige compact desktop sitting on my table and with a big CRT monitor. And that computer took me all the way through to like I want to say my second year of high school when I sort of upgraded to something else.
I think everything you just mentioned is like nostalgia left and right, especially like the mouse. I think it was probably 2 buttons. If I had to guess, it was probably 2 buttons,
Yeah,
the
two
left and right
buttons.
one. I could picture it if anything.
Yeah, 2 buttons, no scroll wheel. Yeah.
Yeah, we're talking about the exact same one. I know what you're talking about on that one. And then I think as you were saying, like when you break down those mouses, there's always that good feeling of like, first of all, to take out the ball, there's like that small plaque at the bottom where you just like you have to twist it first, and then the plaque comes out. And then the ball comes out after. And there's two types of gunk. There's the one that you can just blow on it, and that's what we call dust, basically. But then the other one that's like it looks literally like black glue, if anything.
Yeah, it's nasty.
That's the gunk we're talking about. And it's sometimes on the ball and it's sometimes on that little tiny wheel. I think it maybe had those like 3 or 4 inside. I don't know why I'm describing this, but like this is exactly what people are doing back then, of just like looking at the small little wheels that are inside of that like hole for the ball, basically, and then you just clean every single one of those like tiny wheels. Ugh. I feel like we should have a whole episode on just old retro tech.
Yeah, for anyone who's like struggling to picture this, because like this is ancient technology at this point, it's like, you know, if you've ever looked at like your PlayStation controller and you've seen like all this like dead skin and dirt and stuff just like stuck in the crevices of your controller, like that's what happened to our mouses.
And surprisingly, it was somewhat reliable. I don't think there was a moment where like our mouse died or our mouse had like any kind of major like polling issue. At least like that exposure, I came out saying like it marks a lot of us, right? You get exposed to it at a very young age, and it kind of just opens the world to you, the internet, as we call it from back then. And of course, as you're saying, like that's kind of like the experimental years of like learning yourself, right? Nobody is really, hey, here's exactly how to use a computer. I know there's manuals out there, but nobody really reads the manuals for computers, as far as I know. But when we get a little bit more into like the formal education, if anything, I know at least like I share a lot of my experience in Canada. I grew up in Canada. I studied my whole education in Canada. Around maybe Sec 5, as we'd call it, Sec 4, Sec 5, which is like secondary 4 or 5, which is maybe around high school. We get to choose history or sciences. It was very like 50-50. It was crazy for a 16-year-old or 15-year-old to be like, your life is going to depend on this. Choose history or sciences, and then you just kind of go on with that. So was that kind of like a similar experience in the sense of you kind of got to choose a path, or was it still very like general education all the way up to university, I guess?
Yeah, it's a great question. I think like the New Zealand education system is like kind of similar in the sense that you know, the first few years of high school are fairly generic, but you do definitely start to specialize a little bit like towards the end. And you do kind of need to like, well, saying you need to pick a lane might be a little harsh, because in practice it's actually like pretty easy to study at university, something you didn't study at high school. But certainly like our teachers would impress on us like, hey, you got to be strategic here and pick the right subjects. I'm not an expert on like other university systems, to be honest with you, but at least in New Zealand there's kind of this concept of like university entrance, and you need like some amount of literacy credits, some amount of math credits, and then some, you know, baseline level of credits in general. So as you complete studies, as you complete exams, you earn credits, and like some subjects give you literacy and numeracy. And there are like some university programs which will require a specific subject. So for instance, the Bachelor of Engineering I took, like you must have studied calculus at high school. But in practice, it's very easy to get this requirement waived. So for instance, I did like an electrical engineering paper in my first year at university, which technically required a different sort of physics paper than I actually had in practice, but it was very trivial to talk to the person running the paper and get that waived, and I did the paper anyway, right? So I would say like, yeah, first 3 years of high school in New Zealand is pretty generic. So, you know, your science class is just a generic science, and you sort of split time between physics, chemistry, bio. And then once you get into, you know, year 11, year 12, year 13, your final years of high school, like you start to pick specific, oh, I'm doing physics, or I am doing calculus or statistics, rather than just like one monolithic like math class. So it's pretty flexible. You get quite a bit of time to figure out what you want to do. There's a lot of pressure from teachers, like pick the right things, but like I think, yeah, in New Zealand it's less of a concern. Like our universities are pretty flexible about admitting students to programs.
That's, interesting look to it, just because like I guess it wasn't a hard like you have to choose left or right, but you still got to be aware of like if you want to go into certain programs, let's say engineering, or if you want to go into some med programs or anything, you'll have to lean into some of the biochem, some of the organic chem, some of the, health stuff on that front. The only reason I say this is because I was kind of geared towards a lot of health sciences.
Yeah, actually, now that you mention it, sorry, yeah, one major caveat here, yeah, medical school. If you want to do medical school, you will need to like strategize and like have, very good grades and like, specific sort of science classes. Like, yeah, if you studied a bunch of, history and classics and stuff, and you have like no science, no math, like you will find it very hard to get into a New Zealand med school. That is, I think this is pretty universal across countries, to be fair.
But the exciting part is that like this is the first time I get to dive a little bit deeper into like the New Zealand university experience. That's probably something that I don't ever get to talk about. So even from my perspective of like I did comp sci and you were saying you did computer engineering, which is fairly computer software engineering, which is fairly, in line in terms of the topics that we dive into. But even just for context, I guess, which university was it in New Zealand?
Yeah, I went to University of Waikato. So there are kind of like three options for accredited engineering degrees in New Zealand. It's Auckland, Waikato, and Canterbury. Canterbury is like the most established. Like they were accredited for engineering degrees before anybody else. It was like the first engineering school in New Zealand. But I lived in Hamilton, and Waikato University is in Hamilton, and look, I'm a software engineer. I like taking the path of least resistance, so I went to Waikato. And to be fair, like it is, I believe like for computer science, it's the best school in New Zealand. So there was also that, but like mainly it was a matter of convenience.
That's so great. And shout out to all the people. I was on the same boat of going to a local university in the sense of like, it's there. I went to McGill University. It's a great university, don't get me wrong, but it was right there. And you get to do, the experience, you get to live the experience of comp sci, computer engineering and all that. One thing I'll probably see if there's any similarities is my first few years in university, fairly standard for the first, I guess, like year or two. You would do a lot of like algorithm classes, you a lot of like maybe towards second year you do a bit of databasing, and the first year is like a bit of Java, and then you also have a tiny bit of HTML. You just learn a lot of like fundamentals of anything. Was that fairly similar, or did they already throw you into like a little bit of deep end with like grad courses and like computer vision and like all the other stuff? Like was it pretty standard in New Zealand as well?
Yeah, great question. I think like it really does come down to the papers you pick. Also, I will say like I had a relatively atypical university experience in the sense that I had a bunch of scholarships, and so I skipped like a number of papers. Like I didn't need to do as many of the first year papers. So I can't comment too much on like what a true first year experience looks like. But what I can say is like I think in general like you can design your paper selection in a way that aligns with what you're saying, where it's like, okay, we're going to do like data structures and algorithms, and then we'll step up to like databases, and then we'll step up to like computer vision. But in my case, like I took a paper like Comp 241, which is usually like a second year paper, and this is like you get grouped up with like 3 or 4 other people in the paper, and a final year software engineering student will like project manage you. And the thing that we built in that group is like an app where you could point your camera at a recipe, and we would do computer vision to extract a recipe, and like we had some logic for like fixing up errors in the transcribed text. We were using Tesseract, which is an old OCR library. So in my case, like I did that like my first year, my first semester at university. But that's you need to pick the paper, and ordinarily it's a second year paper. Like in general, like there's a ramping up. At least when I went there. Maybe it's different now that AI is here and taking all of our jobs. I don't know.
No, I think that's absolutely fascinating. Thanks for the shout out to Tesseract. I know people still use it in professional health tech. Like I used to work in health tech, and I know people use that, and it's like it's not that ancient, but it's also something that is so exciting to think about that you get to use as part of a learning setting, as an academia setting, just because that's where you get to explore the most out of it, if anything.
Yeah, my big takeaway from that project was like, man, Android APIs are a real mess because like we built this thing as an Android API and like I think there were like three different camera APIs you could use and like it was very unclear to me like what's the best, right? What gives me the best quality?
But I think like that's the fun part of like even getting to do a bit of like was it a bit of hardware slash firmware in the sense of like we all nowadays, me personally, maybe you do a lot of like web development as well. That's like one side of the world that like we do probably day to day. But back then, did you get to explore a bit
Man,
more
that's a
in that
great
range?
question. Oh, this is unlocking memories a little bit. We never like printed like PCBs or anything. Definitely did like some soldering and like my electric engineering paper, but like I took an operating systems paper and for anyone listening, like who is about to go into like university, like you should definitely take the operating systems paper if it's available at your university. I highly recommend it. It's amazing. But my university had like this custom. I don't know if it's like just a custom CPU or if it was like a totally like bespoke like CPU architecture called it's like RAMP or something, WRAMP. Yeah, the Waikato RISC architecture microprocessor. So we had like these custom CPUs at our university, and like in our operating systems paper, we had to write like assembly to implement like a very basic operating system like throughout the semester, and like that was the thing that we were graded on. And you were interfacing very directly with like the serial ports or things like this, and you had to like you had to build your assembler to a binary and then like flash that on as like firmware. Um, and I'd kind of forgotten about this, but like honestly, this was probably one of the highlights of my university career. I can't believe that it's like, you know, in the corner of my brain. Like I really dug this paper. It was so different from everything else.
It really was stretching like the mind of like how much do you love the tiny details, because like one tiny leg of a single chip could change everything, right, depending on how whatever your multiplexer is with. I think I took an OS course and it was very very similar in the sense of like you talk about that kind of stuff, you talk about the kernel, you talk about all the fun things. But I do agree with you is that if you have the opportunity to study comp sci, definitely take it. It's like you get to talk about this stuff and you get to even at some point just work on it on a day-to-day basis.
I had like the strangest error in my operating system where like so like an assembler like you like it has like a a jump like which is like a go to and you can have labels, right? And I had these two sections where like if I just moved my like labeled sections around, like basically moving like a function above another function, like my operating system worked. And if I didn't do that, like I had a horrendous bug and everything broke. And I had I was totally incapable of like debugging this. It was so strange. And it makes you appreciate like all of the things that like modern languages like take care of for you, because like in JavaScript, like for the most part, like doesn't really matter like what order your fields are defined in like a class, right? But something like C++, like or assembler, like the order you define fields like actually maps like one to one with like how these things are represented in memory, and like it is actually a breaking change to like alphabetize the fields in your class. So yeah, it definitely gives you an appreciation for how much more effective like high level programming languages make us.
And that's definitely a call out, is that if you I'm not going to say this, but if you manage to just go through a couple of years of university and not appreciate tech after that, you might have missed a little bit something, because yeah, it's really the behind the scenes that we get to enjoy doing a comp sci degree at the end of the day. This is probably my last question on the education part, because I could obviously spend years and years on it, but in New Zealand, how, I guess, like multicultural were the classes? And I asked this question in the sense of like I went to university with the expectation of like, oh, it's probably all like just local people of like people in Montreal. Montreal, you go to McGill, and McGill, I guess it's just a school. Just as I've grown up my whole life in Montreal, I was like, by the time I got to the comp sci degree, it was like the big leagues. It was like the world was there. Yeah, people from every country, from Portugal, like Spain, Germany, like India, China, Japan. Like it was the part where I took a like, let's say, the database course, and like there was probably more people out of town than from people living in Montreal. I was like, I just got maybe schooled literally in the sense of like, wait, my mind was so tiny at that point. So maybe from that perspective of what did the classes look like? Was it multicultural? Because I know my influence of being able to meet so many cool people was because of that influence of seeing so many people with different culture and at a very relatively young age. So maybe from your experience, was it similar in New Zealand, sorry, in the sense of very diverse class of people with the same, I guess, interests?
Yeah, definitely. We have a very like healthy international student body. It's probably not like as sort of diverse as like, elite like world class schools where like literally everyone from all over the world is like desperately trying to get in, and so you end up with like, 50 different countries and like one paper. But yeah, like lots of folks from like Asia would come to New Zealand and Australia actually to study at our universities. You get the occasional European, like my electrical engineering paper that I took. Like you'd partner off and work in pairs on during the practical workshops, and my buddy was from Germany. Um, so you get like a decent mix of international students, and something that is I think very unique to New Zealand. A big part of like our national identity is prior to the colonization of New Zealand, there were these indigenous people called the Maori living there, having a good time. And something that I think New Zealand does a lot better than a lot of other like colonial countries is like we put a lot of time and effort into like incorporating Maori culture into like our day to day as New Zealanders. There was like this big Maori presence on campus, and like things like the architecture of the building is like very influenced by like traditional Maori design, and we had a lot of this integrated throughout the university and throughout New Zealand, like more broadly. Like we're an inherently multicultural nation because we have sort of this. We've inherited a lot of culture from the British, who came to New Zealand and sort of settled it. And then we have this like very rich like indigenous culture as well, that we sort of and we kind of like blend the two together, which I think is fairly unique in the world.
I definitely think it is in the sense of history, as you were saying. Like, I mean, Montreal, Ville Marie is only 400 years old compared to like thousands and thousands of years of history. And shout out to Canada, of course. I can't say enough. Same thing where you definitely take the time to appreciate everything that was there before as well. So, thank you for letting me ask so many questions about just being a student in New Zealand back then, because I feel like I really never got the chance to do that. So thanks so much for that. But I mean, reality hits. The way I put this, reality hits everyone. You graduate at some point, right? Congratulations to everybody who graduated. It's not easy, never easy to do it. But from that point, I mean, I share a lot of my experience in the sense of like, now what? That's really the question, where I didn't really do any internships. I didn't really prepare for my future that well. Not that I didn't turn out okay at the end. That's my only defense with myself. But what did that look like after studying? In the sense of, did you already know what you were going to do in the sense? Because, I mean, nowadays you live and breathe tech, which is a very great thing. I keep on saying it. But, back then, what did that look like?
Yeah, great question. I mean, I had it pretty easy, I think, in the sense that like the engineering degrees, so they're sort of like accredited by this thing called like the Washington Accords, and one of the requirements is for your degree to be accredited, students must go through, I think it's at least 800 hours of like practical work experience. So every single engineering degree in New Zealand, like at the end of your second year of study, like you will do a work placement. Like you don't have a choice. You must get an internship, or you must like, do some kind of like, research project under a professor at the university. And again, at the end of the third year, like you must, finish off your 800 hours of practical work experience. If you don't do this, like you just can't graduate. Like this is a hard requirement. So this was helpful. Um, and then I was also very fortunate because in my third year, I took a paper called like software industry project or something. I forget the identifier. Um, and it was kind of like another work placement where there were some companies with like project ideas that they wanted like free labor for. And there were some like research projects at the university looking for the same. And you had to like rank your preferred projects in order. And there was like this local like startup that wasn't super interesting to me, and I put it as like my rank 19 or something. And of course, I ended up getting this project that I did not want to do. I wanted to do the research project where we were like developing a vision model for detecting like cancerous lesions, right? Like that was way more interesting than these guys who basically wanted to make like this like ad builder in a browser. Um, but yeah, I got this and met the founders, and something about me is like even if I don't like the work I'm doing, like I like my personality is such that like I'll always put like maximum effort into it, and like they were impressed by that. So I ended up becoming like their founding engineering hire, sort of like a month into this paper. And the company was still going by the time I'd graduated at the end of the following year. So I just continued with that, right? Like again, path of least resistance, partially, and then partially also like it was just a great opportunity. Like being the first engineering hire at a company like forces you to get better like really rapidly, because you're on your own. Like people have expectations, and there's just like so much to do in like that 0 to 1 stage of a business. And so like I credit a lot of like my career trajectory to like falling into this opportunity, because it forced me to get good, or get fired, I guess.
Yeah, and I absolutely love how you just broke open this window opportunity to talk about in terms of it didn't end up being as scary as you think it was. Don't get me wrong, it was hard, right? In the sense of there's a lot of stuff to build. You can't rely on many people just because like having somebody, more senior than you already are, that's always a luxury to have at the end of the day. But effectively, when I think about this stuff, is the world seems hard, but you were piecing it together. What kind of technology were you dealing with? Was it like completely new programming languages that you had to pick up on the fly, or was it something that you already had a little bit in your toolbox?
I'm far enough removed from this company now that like I can come clean, right? So if you had asked me at the time, like Sophia, like what do you think of the tech stack, or do you have familiarity with this? I would have said, I'm an expert on everything we're using, right? Like you gotta, I was faking it till I made it. And in reality, like it was sort of, it was a little bit more mixed. So like we were using TypeScript and Node.js for like our backend, and like yeah, I had familiarity with that. And we were using React on the front end, and like I was very familiar with that. But like we were using AWS for our cloud, and like I had played around with AWS in university. Like I'd spun up like an EC2 instance at one point and like hosted like a Meteor JS app on it. But like, did I have expertise about AWS? Like, no, I didn't really know what I was doing. So there was a lot of like learning on the job in that respect. And then like I had been like talking to like very technical investors, because like part of my role here was like helping the founders like close out their seed round. And so like I picked up on like from like previous like internship interviews like with this like local grocery company that like infrastructure as code is like a really important thing. And so I was like, we were using Terraform to like manage our AWS account. And like again, like I didn't really know too much about IAC or Terraform. I just knew that like this is something that we can put in our tech stack, and it'll make me sound a little bit more impressive potentially. And so yeah, I think like that's sort of the main thing. Like it was like, TypeScript, React, Node.js, on top of like AWS managed by Terraform. We were using Git and like CI/CD and all this good stuff. And like I had some experience with this. But yeah, like it was my first time like building a real product and not like a project for university or something. And AWS in and of itself, like there is just so much scope there, right? Like you can study AWS nonstop for like a year and like still not know all of the services. There's a strong like power rule here where like like very strong like a 80-20 rule here where like 20% of the services get you 80% of the way, to be fair. But I didn't know this like ahead of time, right? I was like staring down the barrel of like this AWS thing, and I was like, oh shit, how do I do this?
No, that's so good though, because I keep on saying that like you end up managing to build stuff, right? Every day there was something different, and people who haven't worked in that kind of environment don't really get to experience that gruesome piecing stuff together. But yes, fake it till you make it. I keep on saying it in the best way possible, and best light possible. I do that till today. I could be working in tech for 30 years, and I'd still be saying, yeah, you just kind of fake it till you make it until somebody, as long as it doesn't involve hurting people.
Yeah, something that like really sticks in my mind and like was very important during like my formative years as a software engineer is like it's this article called "The Code I'm Still Ashamed of," and it's like this guy talking about how he's a software engineer and he gets tasked by like this pharmaceutical company to make like a quiz widget for them. Like someone's gonna answer questions about like their symptoms and stuff, and the design brief said that like, okay, you're just gonna ignore all of these answers. Like at the end, you're gonna push like this drug that we're trying to sell, and the guy like implements it and ships it to production, and like doesn't think too much about it. And like it's like an antidepressant drug with like some side effects. Like it makes your depression and whatnot like a little worse in the short term, and that needs to be like managed by a healthcare professional. And guy launches it, and like a month or two later, or something like this, he sees in the news like someone has, taken this drug and gone and like unalived themselves, right? And he also finds out that like his sister has also been taking this drug, and it's kind of like this big milestone in his career where he takes stock and thinks like, oh shit, like this is like partially like I'm like culpable here, right? Like I'm the person who built this widget. I don't know if this specific person used my specific like quiz to get on and take this, but like it could have been, right? And so it's sort of this article which talks about like the need for us as software engineers to have agency over the work we're doing and think like, okay, like if I do this, like what is the downstream impact here? Like, am I causing harm? And I'm so glad that you brought up that point of like, don't hurt people, because yeah, like we absolutely have responsibility for the things that we build and ship out into the world, and we should always be keeping that in mind. Like we should always be evaluating the work that's coming in and be professionals about this. Civil engineers or architects do not sign off on building designs which are like obviously flawed and will like crumble, right? And we need to do the same, I think.
But even from that initial, I guess, like first time role, and thank you for sharing so much about the technology even back then. Like this is deep Perry lore, but if it wasn't for Meteor.js, and I'm so happy that you mentioned it, I don't think I would have had a career in web development. It was crazy. I think it was wild in the sense of like not that many people know about it. I think they're still around, but like I remember using like probably the first version, like 0 point something, I don't remember, but it was something about like, hey, look, you don't worry about your back end, you don't worry about your front end, it's just like out of the box, and it was like the least secure thing I could think of, but it worked. it worked. Everything worked, and it was just like, oh, fair.
There's a really great retrospective on this framework, by the way, by Sasha Grief, I think. Like it's like going over the history of Meteor from like the very initial community to like the sort of demise of the framework. And like interesting like connection here for anyone who doesn't know, like the guys who make the Apollo GraphQL products, like they're all they all came over from the Meteor JS project essentially.
Absolutely brilliant people. But how long were you at that initial role for then? Just because I know nowadays, I mean, you've done many other different roles from then.
I think I was there just under like 2 years, something like this. I think maybe I was like, yeah, like 1.7 years or yeah, something like this.
I think even from those years of like just day to day battles as you go into, and you wore many hats. Don't get me wrong, you weren't only coding. That's probably one of the mystery or the behind the scenes thing where people just assume that engineers code all day. As you're saying, you talk to stakeholders, you do a lot of planning, just like any other engineering professions out there, and you also do a lot of project management. But since then, you've definitely led on a lot of different roles: software engineering, lead engineering, even director of engineering at some point, and all that. From your perspective, how did that, I guess, like evolution happen in the sense of, were you, I mean, this is the dumbest question. Nobody's really like a title chaser. It's like, I ask myself this question, am I title chasing all the time? Like, what did that perspective look like? Just because I came out saying this is my greatest topic on the show is being able to talk to other engineers that have lived through it and seeing what their perspective on it. Because, I lived it very differently in the sense of people just give me responsibilities. People are just like, oh, you want to do this? I'm like, sure, why not? And then it ends up being not being coding, right? It ends up being like, oh, there's like too many meetings, figure out what's going on, or we're spending too much time in stand-up, or somebody has to talk to this vendor because this contract makes no sense or whatever. There's a lot of stuff like that that pops up. So that's at least my experience. It wasn't anything about like, oh, I want to be specifically only known as an engineering manager for the rest of my life kind of thing. But maybe your perspective on this topic, because you've definitely done a lot, which is why it's great.
Yeah, no, I would just double click on like your experience, honestly. Like I so like I left Codimation, which was the place where I was like, founding engineer. And we were like gonna run out of money, and like you can look at like the rate at which we're acquiring customers and realize like, okay, there's no possibility of a round, or this is a waste of time. Like we should just return investors' capital and move on with our lives. So I, was looking for a new job, and there were a lot of like really interesting opportunities out there in New Zealand at the time. Like this was sort of, 2021-ish when, the market was just on fire. And, shout out to Flickit. I was in the interview process with them. They're trying to break Ticketmaster's monopoly on the ticketing industry. Love that. Okay, we don't like Ticketmaster. Um, but I started interviewing with this company called Crimson Education, and the thing about me is like, um, whenever I like look for a job, like I don't care so much about like the title, but I care a lot about like what we're doing, right? So the advice I always give to people that I'm mentoring who are like looking for a new career is like the most important thing is to find a place where like the corporate Kool-Aid like tastes good, right? Like you don't need to be like 100% like on board with everything. Like you don't need to like live and breathe it, but like it should be palatable, right? Like you should be interested in the mission. And education is like such a passion project of mine for like two reasons. Like one, like I didn't have like the smoothest high school experience. Like I was like kind of like a weird kid with not very many friends. And in many ways like not challenged properly by the education system. So like that's like, I've got like a chip on my shoulder, I guess, which makes me interested in education. But then more broadly, like I just think like this is such a force amplifier for society, right? Like if you make like a 10% better education system, like imagine the dividends that pays off over like the next 10, 20 years. And that's like why I got into software, was this idea you can ship something and make like 10 million, millions of people's lives better like right away. So yeah, interviewed at Crimson for like a senior software engineer role. I just really loved the way that the gig had been sold to me. It's like we're upending the education system. We're gonna make all this stuff better, and that like appealed to me. I was like, okay, cool. This is Kool-Aid. I can see myself drinking for the next like few years. Um, and then yeah, just like fell into a team lead position. Like it was sort of my third day on the job, and I had my one-on-one with the VP of engineering, who was like personally like managing like 40 people in the technology department. And he was like, hey, like we're looking to introduce like another layer here, like team leads, and like we think you'd be great, like you're crushing it. um, and I had to think about it, like, okay, do I want to do this? Because like I think a lot of people make the mistake of thinking that like leading people is a straight promotion. um, and depending on the specifics of the role, like sure, but one like the IC and manager track is very sort of different, like different skill sets, and it's not a straight promotion, or at least it shouldn't be. A lot of companies make this mistake. And I decided, like, okay, yeah, this is interesting. I'm keen to do it. And so I got that. And, like, honestly, like, basically every other, like, role has been a similar story where, I've just been trying to do, like, good work. And someone has shoulder tapped me, like, hey, by the way, like, do you want to do, like, do you want this extra responsibility? Like, and I generally say yes. But I would say like a shocking lack of strategization and forward planning on my part. It sort of tends to be. I always explain it to people as like I'm lucky I'm in the right place at the right time, and people get very upset by this because they push back like, oh, you worked really hard, and like I think that's part of it. But the other thing I would say is like the number of roles like up the career ladder are like pretty limited, and like you can be like the best software engineer in the world, and like there just might not be a position, right? So like a big part of this is like putting yourself in sort of the environment where this stuff is possible, and like there's space for you to move up. And the intelligent thing to do is to be strategic and evaluate the company. Like, where's it going? What's the trajectory? Is there an opening for me here, like 6 months down the line? Um, I've never been super interested in this stuff. Like, I just really love the technology and like building valuable products for people. And so I've always just chased like what company can I get into which is like most aligned with my interests, because if I'm interested, like I'll instead of giving like 100%, I'll give like 110%, and that's like fulfilling to me. And it's just so happened that this is like this strategy, if you want to call it that, has like worked out for me.
It's not an easy thing for people to recognize it in you to begin with, in the sense of you deserve it. I think not everybody gets on the street where they get called, tapped on the shoulder to be trusted with stuff. Is probably what I'm trying to say here. So I keep on saying that, like, I'm so happy to even hear your journey so far of working on so many projects, because I definitely do know 9 out of 10 people are not getting tapped on the shoulder to look back and looking into that. So that's at least how I would put it.
Yeah, and like something else that I'd say, like I'm sort of increasingly building conviction on this idea that like we always say that like it takes a village to raise a child, but we kind of think of like our career, like or at least a lot of people I know think of their career as like they're an island, right? And it's like, okay, I need to get better at stuff. But like a lot of the reason why I am good at the things I'm good at is because like I've been able to work with like really smart people that I've like picked stuff up from. And I think it's also important to recognize that like it takes a village to make a great engineer. If I sort of think about my approach to work and like the things I know and like the things I value, like a lot of this has been shaped by the fact that like I've worked with someone who has impressed on me the importance of this thing, and I've carried it forward. And I think, if I had to be like brutally honest, like, what percentage of things are like truly unique in my brain? Like, I think most of the stuff in my brain is like I've remixed ideas and like synthesized them together from people I've worked with. So, yeah, the environment really, really, truly matters a lot.
especially how we're not trying to rebuild an airplane from scratch every day. We're trying to build upon the knowledge behind of, people having built aircrafts and really great technology and projects. And you're really definitely echoing that attitude, which is great. And I really want to highlight the part you were saying, like, it takes a village, not of only engineers, but a village of everyone. I feel like behind the scenes, people don't hear engineering people, give their thank yous to QA people and give their thank yous to designers and give their thank yous to product people. Every spec of product management, project managers, TPMs, like those are the people that really gets the good influence. So thank you for sharing a lot of that. That was super great. Nowadays, a lot of time spent on working on Rye.
Yep.
That's the part where you're currently the head of engineering at Rye. And then everything that we spoke of all the way in the sense of your experience so far, this is something that you apply to your day-to-day, right? When you're working with other people, and also, I guess, like, still contributing to technology behind it, because it needs a direction. Every technology architecture needs a direction behind it. So maybe just to help people get familiarized real quickly with Rye to begin with, what exactly is the product at Rye? I know we already gave a high-level definition, but more specifically, what are you building at Rye at the moment?
Yeah, there are a lot of ways that I can explain Rye. The metaphor that I like to use is like Stripe is to payments as Rye is to commerce. So you integrate with Stripe to add, take card payments. You integrate with Rye to add like online commerce to your apps. You can sell like products from any store on the internet. And this is a remarkably deep problem domain, surprisingly so. During my interview process, like, I had been told that like we were solving really hard problems at Rye, and I sort of thought in the back of my head like, oh, it can't be that hard, right? But once you're really immersed in the space, it turns out that it is quite difficult. So we're working on a few different things, but the main thing for us is like, we really care a lot about like the stability and the scalability of our systems. So we have an API where, you can take the URL of any product on the internet and punch it into an API endpoint, and we'll turn that into like, structured product data. And then you can take the ID of that product and throw it into a shopping cart. And the shopping cart can contain products from any number of stores. You can have, a product from Gymshark alongside a product from Alo Yoga, alongside a product from Amazon. You can pay for that cart through a few different like flows, and we handle all of this beautiful complexity involved in, okay, we have a shopping cart with like products from 3 different stores, some of which we have like, official API integrations with, some of which we do not. How do we handle like fulfilling this order, right? And there are all kinds of interesting failure modes that occur here. So for instance, it's entirely possible that, we place the order with 2 out of 3 of those stores, and then in between us, like starting to submit the shopping cart and getting to that 3rd store, like that product's gone out of stock. How do you handle that, right? Like these are all like external systems we don't have control over. It's not like we can do like a 2-phase commit or a saga pattern here. Like the product's just out of stock on this external system we have no control over. So, our day-to-day is like really like we're spending a lot of time solving like these sort of very complicated, very sort of specific and technical like failure modes and papering over them, because our perspective is that people integrating with us shouldn't have to think about this, right? We should just have a very elegant sort of story of how we abstract this complexity away, in the same way that Stripe prevents you from having to think about all the fine-grained details of how payments happen. So this is what I'm spending most of my time on, is sort of, thinking a lot about these different failure modes and complexities, and like thinking about like, okay, like how do we solve these things in a sort of sensible manner.
Yeah, immediately when you started describing that, I was like, yeah, the async is going to kill everybody. I feel like the fact that there's so many, whether you guys have jobs behind the scenes, whether you have like just a queue of massive stuff going on, I feel like that's always the one of the most complex problems in tech.
Yeah, and it's touching money, right? Like people will rely on us to make money. We can't go offline. We can't have like weird accounting issues. Like there are very strict sort of correctness requirements on our end. So it's crazy.
One thing that I'm always interested is, do you still get to touch the code, I guess? It sounds like a very basic question, but one of the things that we talk about when you evolve in the world of technology is how much code you touch, basically. How much of I-seeing versus how much of like project management, people management, and all that kind of stuff. So what does a day-to-day look like? Or maybe what's a very corporate way of putting this? What's a quarter look like as a head of engineering at Riot? Like what's that?
Yeah, it's like I'm very big on like I like writing code. I wouldn't take a job where I don't get to touch code. So this is just like if you can ask me this question any year and it will always be the same. Yeah, I touch code. And I'm probably around like 25-30% of my time is spent on this, and then the rest is like meetings, talking with customers. Like, I was in London and met with like one of our big customers, road mapping, like giving feedback to people, like reviewing designs and things like this. So yeah, I still touch code. I'll always touch code. Not interested in not doing that because, I love code. But yeah, about like 25-30% probably. It's also like a small, like we're a small company, right? We're something like 16, 17 people overall. And so like, everybody has like IC responsibilities because we're still a fairly early startup.
That is such a great perspective. The way I put this is I've worked at different companies where you have the people who are responsible for the roadmap, the engineering roadmap, who do touch code. And then you have the comparison is people who are responsible for the roadmap and they do not touch code. It's like a very big night and day difference. I can see it from like a mile away what the roadmap looks like, and it's completely different. So I'm so glad that I'm definitely on the side of people who are responsible for the roadmap to also touch code. Like there's that kind of synergy if you're able to have that.
Yeah, like estimation is like, estimation's so hard even if you're like expert on the system you're estimating a deliverable for. Like the idea that like you would be able to define like a sensible quarterly roadmap. Oh yeah, we're definitely going to get like all or most of this shipped out without like any kind of like familiarity with the code base like seems pretty dubious to me. And yeah, sure, like you'll have some people on the team that like you can consult with to try and get their perspective on your proposed roadmap, but like communication's always lossy to some extent, right? I think it's it's ideal if you have just like internal expertise on the system that you're road mapping for. Like I think it's very hard to do that properly without that.
And especially how you already shared a bit in terms of how you juggle a lot of it, right? You spend some time writing code, you spend some time designing the roadmaps, and some time meeting the clients directly, because immediate feedback is so precious nowadays, if anything. But one thing I maybe want to just dive a little bit into is this term DX, developer experience. There's a lot of ways of looking at this, right? There's people who has a product who isn't built for developers. There's people who talk about DX in the sense of, here's how we make our internal employees more efficient. Here's how our engineering team will operate. And then there's also the other part where if you do have a product that is catered to developers, which you guys do, which is like absolutely insane. So now I get the opportunity to dive into both of those. I get to have both pies is what I'm trying to say. We're gonna talk about real quickly in the sense of like building a product for developers. I keep on saying it's one of the toughest crowd on the planet. But what are common, I guess, like concerns designing your product when you think about the end user as being somebody who's genuinely, I guess, like technical, attentive to details, attentive to the fact that, hey, what's the difference between a 401 and a 402? I don't think anybody has ever used 402 before. I don't recall anybody integrating that. But maybe from your perspective on just like leading engineering projects like that, what are the general concerns you would have building a product that is catered to developers?
Yeah, I think like so, building products for developer, like building API products for developers is like probably the hardest thing you can do. Um, I struggle to think of another business pursuit with the same sort of fundamental difficulties. So, if you are in the business of like selling, we're selling tools to professionals who are going to use them, right? In much the same way that, maybe you are a paintbrush company and you're going to sell paintbrushes to artists. But the fundamental difference here is that, like, painters don't make their own brushes. Builders are not making their own, like, hammers and nails. Software, like, API products for other developers is just fundamentally different from any other, like, tooling company because you are selling a tool to someone who could actually just go and make that tool themselves. And so there's always this undercurrent of like, we're kind of competing against our customers' engineers in a sense, because we're always competing against sort of like the null hypothesis, right? So people are evaluating our product and thinking, okay, do I want to integrate with Rye? Yes or no? What about the null hypothesis of us just like building this ourselves, right? And as like an engineering manager, as a team lead in the past, like I have absolutely evaluated, vendors in the past and asked this question, like, hey, should we take on this vendor dependency? Should we not just build this thing ourselves? It doesn't seem all that difficult. And software engineers, I will say, have an uncanny ability to sort of overestimate our own abilities and underestimate the domain complexity of the thing we're about to go build. So there's just like these psychological biases that are not sort of in favor of the company selling a developer tool. So the number one concern is always just like, it comes down to quality and ease of use and ergonomics, because if we miss if we miss too much here, like our customers are going to go through that discussion of like, hey, like, should we integrate with Rye or should we just try to roll this ourselves? And, I can say from personal experience, if anyone tries to roll it themselves, they'll have a hell of a time because it's very difficult. But again, like there are these psychological biases where we sort of simultaneously overestimate our abilities and ability to move quickly and underestimate domain complexity. So, a thing that I'm very passionate about is this sort of difference between internal developer experience, how productive are the engineers like at our company, are we able to move quickly and ship stuff, and then balancing that against the external developer experience, like how easy is it to get up and running with Rye? What is our time to hello world? Are our docs good? Because sometimes these two concerns are not perfectly in line with each other. And a really great like pet example I have of this is I was mentioning, the fundamental use case we support is you can take a URL for a product, plug it into our API, get structured data, and check out that product. That endpoint for turning a URL into structured product data has a bit of a catch to it. In addition to giving us the URL, you need to also specify like what marketplace that product is being sold on. So you need to tell us like, oh, this is a Shopify URL or this is an Amazon URL. And this is a very old endpoint. It's been around since like day one. And it makes a lot of sense why it was designed this way initially, because it keeps our internal code base very simple. We don't need to infer the type of the marketplace. We can just take this input and run with it. But the flip side is, okay, it's like very easy for us to implement this and reason about it, and like testing it's super easy. We don't need to worry about like the shifting target of like classifying a product page and figuring out the marketplace. The flip side is like now we've exported that complexity like over the fence, and now like the question is, okay, I'm trying to integrate with Rye. I have a product URL that like someone's given me because maybe I'm a wishlist application and they want to add this product to their wish list. I need to figure out what marketplace this is being sold on. How do I do that, right? So these two things are sometimes not perfectly aligned. And for me, the emphasis is always on external developer experience, even if it comes at the cost of internal developer experience, because that's the thing that ultimately enables us to get customers, us being easy to use. And I think even more broadly, I'm big on this idea of like what I call like caller-oriented design. And the way I think about this is like, if you have a function like add, x and y, return x plus y, you only ever have one implementation of that function really, but you often have more than one caller or consumer of that functionality. And so the trade-off for me, and it's always at least bare minimum a one-to-one relationship, right? So for me, the way I think about this is like, I would always rather have a more complicated implementation of that add function if it makes consuming that function easier, because worst case scenario, it's one-to-one. Generally, it's n-to-one, and you have much more consumers. So a 10% more complicated add function that makes consuming it 10% less complicated, that pays off. And even something like 10% more complexity on the implementation, 4% easier consumption also probably pays off, because you probably have more than two or three consumers, and that's certainly the case for our API. We have much more than just two or three people using us, right? So yeah, this is the way I think about it. Like there's sort of these the big concern for us is we are in some sense competing with our customers, and we need to ship interfaces that are better than the ones that they sort of dream up in their sort of platonic ideal, in order to preempt that discussion that always happens whenever you're evaluating a vendor of like, should we take on this dependency or should we do it ourselves?
Behind the scenes, I was just like smiling from ear to ear in the sense of the way you're describing from the examples that you just gave, in the sense of like, what are the trade-offs if we make the endpoint easier for the end user, the external user? What is the trade-off? Is that you internally have to make it a bit more complex to implement it. I think that's a set of problems that literally, I keep on saying, like less than maybe like 25% or even less than a quarter of the companies have these kind of like problems that they have to solve at the end. And as you're saying, you're probably juggling those kind of problems left to right every single day. That's probably where the excitement of just thinking about how to solve all these end up being. One thing that is actually really cool is when you're talking about these developer products at the end, you already emphasize the trade-offs, right? And you gave like, even when you're sharing like, oh, if it's like 10% easier on this front, but then it's like, if you think about AI models, you talk about all these factors. There's like these different variables into it. It's very similar to what a lot of you're trying to think behind that. But is there any, I guess, like internal DX tools, like just random callouts that made you and your team like just enjoy coding more? Sorry, this is like literally the software engineering geeky part of Perry, to be like, I talk about all these DX tools that my favorite thing in the world. People know this about me. I absolutely love pre-commit. Like anything that blocks a developer from pushing code for a reason, not because of willy-nilly somebody wants 80 characters in a line instead of 40. Like, no, I'm not talking about those. I'm talking about any kind of like process, developer experience stuff. Is there anything you want to call out that made you, your team smile just a little bit more playing with code?
Yeah, look, big fan of pre-commit as well, and like just a big fan of like automation in general, right? Like if something like if an issue with code can like be detected in an automated fashion, like I love that, because it just frees up your mental bandwidth for focusing on like shit that actually matters, right? So one thing that we added kind of recently-ish is this tool called GraphQL Inspector. And what it can do is like whenever you change your GraphQL schema, so our API is GraphQL, it will take a look at the diff and tell you like, hey, you just introduced a breaking change here, or hey, like this change looks risky. It's not a breaking change, but is this actually what you wanted to do? You're reusing like an input object type across like two mutations, which is a big no-no. Love GraphQL Inspector because previously, like, we had to spend a lot of effort thinking, like, hey, like, what are the downstream impacts of this change? And not all breaking changes are immediately obvious. You need to have some level of expertise to identify all of them. And GraphQL Inspector detects, like, I would say like 90% of issues early. And we have a process for going through breaking changes, but it's something we want to avoid because it's so hard to action a breaking change on a public API like ours. you know, Internally super easy. You have organizational leverage, like you own the whole thing end to end. Like that's just not the space we're in. So yeah, I really love GraphQL Inspector. And something else that we've been experimenting with recently are uh, AI code review tools. So we're using this thing called Code Rabbit, and it's a little noisy. I don't know if we'll continue using it over the long term. But it's exciting that like we're getting to a point where, in theory, like we might be able to automate like a lot of the sort of grunt work involved in code reviews. Like it's a huge time investment at our company and elsewhere.
I was so obsessed when you were jumping between the part of developing for external users and the way of making their lives easier, but you're also dropping all these examples of how to make your internal team of developers dev so much better. I mean, of course, you mentioned CodeRabbit. I think there's another one called Cube out there. There's a lot of these like automatic integrated code reviewing, and as a dev, people love and hate code reviews. The wars that people see in their PRs at the end of the day, that's always a fun topic. But the other part that maybe this is my philosophy, because of course, like you see so much aspect of engineering, but I think the word I'm dropping here in terms of documentation, not only is the automated part great, right? When you're talking about when you're building products, you want a lot of automation, but at the same time, you do also want a bit of resources to help yourself if you get ever stuck with anything, and that's where the documentation plays a big part at the end of the day. Of course, I love reading docs. I read a little bit on the Bride docs. Those are great. I keep on saying that if I could understand the concept within like just minutes, then I'm a happy camper. And you do have a philosophy behind writing documentation, right? Or is there like a specific way of thinking about presenting documentation, just because it's just as important as the automated stuff, I guess?
Yeah, so we handwrite a lot of our documentation. And there's kind of this framework that I'm a big believer in. That we're still candidly in the process of rolling it out, but it's called diataxis. And it's something that if you look at like the RIDocs and archive.org from like 9 months ago before I came in, we had a lot of like what this framework calls API reference material. So it's like, here's our specification, here are the API operations, like go get it, right? But this is not enough for someone to run with and succeed with. You need other things as well. So the diataxis framework kind of breaks it down into two sort of dimensions. There's kind of like, are people trying to acquire knowledge or apply it? And are people trying to I forget the explanation here, but the y-axis goes from like increasing level of action versus increasing level of like cognition. And so the idea is like, yeah, you absolutely need like reference material. This is great, right? You're using it when you're applying knowledge, and it's very cognitive. But you also need things like explanations, right? Like, why are things the way they are? And you can't auto-generate that from a schema. You also need like, step-by-step tutorials. How do you achieve this like very specific goal with our API? You need like how-to guides, which are more sort of broad, like based on like a larger business goal that you're trying to achieve. And so we still have a long way to go here before our docs are perfect. And, obviously there's a trade-off between, how much do we invest in our docs relative to the core product? But, I'm a big believer in like this diataxis framework for, systematically approaching documentation and thinking about it in terms of these four sort of quadrants of like reference material, explanations, tutorials, how-to guides. My preference is always to lean really heavily on those how-to guides and explanations because, yeah, sure, like we're targeting a technical audience and the reference material is very important, but at the end of the day, like people are not using our API for out of idle interest, right? They're using it to achieve something. They have a business problem they're trying to solve, and those how-to guides and those explanations are really, really critical for helping people solve their problem faster. Instead of like going through reference material and trying to like piece together like, oh, okay, maybe I use this API operation, like maybe this data type is what I want. Like if we can just explain this and give sort of like a linear guide, like this elevates our documentation. And this is one of the reasons why Stripe has been so successful, is because actually it's really hard to find the API reference material. I've tried to find like, the type definition for a payment method so many times, it's like buried in their documentation. They just lean with all these tutorials and how-to guides and explanations of like what's happening and sequence diagrams of webhooks. And so, trying to imitate that, I guess.
But even then, I think what's impressive about you and the whole team, of course, behind Riot at the moment is the alignment and the understanding of how important it is. Because as you're saying, you have to juggle the DX for the users using the product. You have to juggle the DX of your internal users that are probably also dogfooding your own product at the end of the day. And then you have this documentation that needs an alignment. You need to have all three of those parties completely synced. This is like probably the most important of having them synced, or else if you lose the source of truth, then at that point, and anybody can make up stuff. At least like maybe my old school way of thinking this was probably like, if you want a source of truth, make it probably as public as possible. As in like, if you want some doc to be like reliable and updated and maintained, is that, yeah, just give visibility to it. Like the more visibility, the more chance of somebody looking at it and breaking something or messing up. It's a good accountability factor that you should probably keep that very, very clean. So from what I'm hearing is that's something that you guys also pay attention to a lot.
Anyone who's worked with me will know I'm a big believer in like this idea of like working in public at work, especially in a remote environment, which is what Rye is. Like we're all fully remote. Some people co-work together in like New York City, but we're geographically dispersed. And major anti-pattern I see at like remote companies, pretty much every remote company I've ever worked at, is like people abuse direct messages, and they will ask work-related questions or like debug issues in DMs, and like, yeah, sure, you make progress, but like, man, think of like how much better it would be if you publish that and the engineering channel and everyone can see it, and like if someone runs into this issue again and they search Slack, it's going to come up, and like, man, wouldn't it be great if like at the end of that like thread in the engineering, like you turn this into like an actual like runbook in Notion that's like, and you assign yourself as an owner and it's on you to keep this up to date. Like big believer in working in public, and this is like something I talk about at Rye like on a more than weekly basis, because it's so important for like knowledge transfer, and I call it like getting the sponge factor up, right? Like I want everybody to understand what other people are doing, and like I want people to be collaborating, and you need to be very intentional in a remote environment in particular, because this stuff just doesn't happen naturally when you're all at home on Slack and you can't sort of overhear conversations and tap someone on the shoulder.
I swear we didn't rehearse this. Like, I know we talk about this topic of post it in Slack. Even like today, I was like, just re-ask this question in this channel. I've said this so many times, and there's also a lot of channels where there's probably like a couple hundred people, and I'm literally going to be the one going in there, describe my problem, be very, very intentful in terms of here's the CTA, here's what the action that needs to be done, and I literally CC the hell out of the person who asked me this question to begin with. I'm like, look, this is where it should happen. So I'm more of a show by example, if anything. And I think maybe you'll probably agree with this part, is I don't even know why I'm explaining this, that people don't want to look stupid or sound stupid in front of a lot of people. And I'm like, well, you're forever going to be stupid behind the closet or like behind like whatever you're hiding. Because if you don't do that, then you're never going to be able to like articulate like your questions better. Not physically speaking, but just writing it better. So I swear we didn't rehearse this. It's something that I keep on dealing on a daily basis. Be like, Yeah, just re-ask that question in this specific channel. That could be an episode by itself in anything. Just how to ask questions in different Slack channel. But maybe this one of the last topic that where you might dive into is you already mentioned remote teams and even the fact of like the asynchronous of communication, but even like the velocities of stuff, or maybe you're re-explaining the same thing 4 different times because somebody might have missed like a DM somewhere and everything. So what are those, I guess, like challenges that you face, I guess, like as a remote team in the sense of keeping information together, or even the part of people not having organic conversations? I feel like as part of your role, or even just as part of somebody working in a remote team, everybody has to think about it, or somebody has to think about it at the end of the day. So what is your approach to that nowadays?
Yeah, I mean, a big part of this is like leading by example, right? And demonstrating like, hey, this is how we, communicate, and like this is sort of the expectation. We also, we just had like a big communication workshop where I took like, everybody at the company through like, hey, here are like 8 best practices, okay, that we need to internalize and consciously think about. Because the thing about remote is not that like, it's not that the skill ceiling is higher than in person, it's just that like the skill floor is higher. So I don't think there's a meaningful difference between in-person community, like a meaningful difference in difficulty for in-person versus remote at like the 1 million person scale. But you start running into issues a lot earlier remote compared to in person. You can put 30, 40 people in a room and it'll just work. You can't put 30, 40 people in Slack and have it work. And the stuff is so unnatural to us because we're used to interfacing with people face to face. And so it really does just come down to like, you need to lead by example, and you need to continuously reinforce like, hey, this is how we do things, and we do it for a reason, and sort of being very candid and giving feedback to people when, they miss the mark, right? Like they're abusing DMs, or, they gave a really sloppy sort of message, and like, just 10 more seconds would have been, perfect, or something that
Please include the UUID. That's what I keep on saying. Please include a UUID so somebody could find a log somewhere.
Yes, please, or a link, yeah. And something that like has recently started is like, AI slop, right? Like people go on ChatGPT and get it to spit some stuff out and like copy paste it. And it's like, hey, bro, did you like review this? Like, it doesn't look correct to me. It feels very AI-ish. But it's like any other management issue, right? Like you lead by example, and you make expectations clear, and you consistently sort of talk about this, and eventually it becomes like part of the culture. But it requires a very high degree of intentionality, and like you need to like make it happen, right?
This is honestly one of my favorite topic of conversation. Like, I know we're devs at the end, we're software engineers. I know we're supposed to like talking about only about code, but this kind of topic of like the engineering ops, like the engineering way of like doing stuff maybe more efficiently, I could spend years just doing this all the time and doing a little bit of work of that at the end of the day. But there's also no way I can dive into sophiabits.com. Like, all the topics that we just discussed in terms of like documentation, in terms of like all these like processes, in terms of like even some of the async topics, if anything, like you dive so much into that. Sophiabits.com, that's a blog that you've ran for years and years with, I think I counted 105 articles, because obviously I love counting stuff. And how did I count that? You don't number them either. It's because I go into the HTML source file and I find the exact tag that you have, and then
there's an undocumented API endpoint on that site which tells you the count and the number of words as well.
Easter egg for the people. Definitely check out sophiabits.com. But maybe just because I'm always impressed in the sense of you already do so much as your, I guess, like day-to-day job, right? As your role at Rye. And you also find time to doing this knowledge share. It's definitely part of your core. Like, it's definitely part of who you are at the end of the day. So what does that process look like? Where do you get all this inspiration from? And how do you manage to share so many cool topics to everyone?
My process is, I get my inspiration from work. Like I see myself as like I'm an operator who writes you know, like I'm not a writer who operates. I'm not a writer. Like I'm first and foremost like a software engineering professional, and then I write on the side. And I think that's like important, right? I don't think of myself as like a blogger per se. Um, but you know, I get inspiration from work. Like I'll run into something that's, you know, fiendish or pisses me off, or you know, I'll run into something that like I don't really understand all that well, and like my way for working through this is like I will write an article. So, you know, like one job ago, like we had an issue where people on the team were, you know, in my view, like massively overcomplicating things and, you know, over engineering, right? And so I wrote this article, but we're the architecture astronaut, which is sort of talking about like, hey, like it's important to be pragmatic and make good decisions. And like, you know, if you have like a database query that's running slowly, like maybe your first instinct should not be to just immediately spin up a microservice. It might be worth understanding like what is the root cause here, right? It's easy to layer stuff on top of each other. It's hard to peer under the hood and understand like what's going wrong. And I ended up pairing with someone on my team at the time, like diagnosing this query. And so another output of this was like I wrote a little like how-to guide on like how to look at a PG stat statements table to find slow Postgres queries and sort of debug them. So a lot of it is just informed by my work. Like when you read writing from my blog, it is written in blood. It's coming from my practical lived experience as someone who is building products and has ran into a problem that you are potentially going to run into like a month or two from now. And, you know, potentially you can avoid that issue if you read my article.
And they're also digestible, and they're all like, they're bite-sized. They're a good TV show, if anything. That's how I would describe it. It's just good TV and good writing over there. So definitely sophiabits.com, definitely check it out on that. Okay, actual last question. Top 3 favorite apps at the moment, whether it's on your phone, whether it's on computer. I mean, for example, at work, we keep on saying Slack. I love it in the sense of I never use Teams at work, but it's an application that runs my life. I know some people have specific to-do lists, for example, that they're in the app. So maybe for Sophia, top 3 apps, maybe top 5 if you want. Honestly, top whatever apps, number of apps that runs your life that you really appreciate that you have.
Yeah, look, I gotta shout out my boys at Basecamp, 37 Signals. Hey, so they have like an email product. Imagine launching an email product, right? Why would you do this? But they have a product called hey.com. I love it. It's so much better than any other email service I've ever used. It's very opinionated and sort of puts you on rails, right? I don't have 10,000 emails in my inbox like I did with Gmail. Love that. Number one. Going down the list, I mean, look, I would be remiss if I didn't say ChatGPT and other sort of, you know, LLMs. Like, I get a lot of value out of these things. People who work with me might be surprised because I'm always pushing back on like AI generated stuff at work. But genuinely, like, this is a useful tool for going faster and you know, being more efficient. It's just, it's really easy to abuse. But I love, you know, all the LLMs out there. It's hard to pick a favorite. Whether that's ChatGPT or talking to Claude, like amazing, love it. And then I would say like, yeah, it's probably Slack. Like I spend so much time on Slack, like every day, at work and, you know, there are also like just generally good Slack communities for like, outside of the day job, like nice, you know, leadership communities and things like this where you can really learn a lot. So those would be my top 3. They're kind of boring. Number 1 is an email client. If I had to stretch to 5, I love Copilot. Like I was very skeptical about Copilot for the longest time, but really, really starting to come around and I like it. And probably number 5, like it would be Apple Notes. Actually, you know what? I would say Apple Notes number 4 above Copilot. Like for the longest time, my blog was being run out of Apple Notes. I moved to Notion just because like it was easier to turn into Markdown. But Apple Notes is like my go-to if I ever need to track anything at all. Like I do that. Like, I don't do Kanbans or special to-do apps. Like, Apple Notes is good or reliable, and I love Apple Notes.
Your list is great. I keep on saying that for the people who loves productivity or like who loves efficiency, that is like music to their ears, and to my ears, if anything. So thank you so much for sharing. And at some point, this is like a random tidbit, but you might, once the company gets bigger and bigger for Slack, companies usually disable the leaderboards of who posts the most messages on Slack. Like, I've seen it so many times. This is such a specific Slack conversation. We're not going to dive into it, but I've had this conversation too many times, and they're like, why is Perry at the top of the board for the past 3 months in a row? Like, I swear I do work. I swear I work at things. Stop looking at the leaderboards. Anyways, just because you've seen so much in tech, going from literally the front person running into a storm and solving all the problems, all the way today of solving not just your problems, but like solving the problems of a million people, if not more at the end of the day. What is probably like the best advice for people who are either on that journey at the moment of, building a product, managing a product, talking to a lot of people, or just somebody who wants to get into that career of being the founding engineers? There's a lot of pressure, but there's a lot of like positive behind it. I guess, what's your general advice of having lived through it and keep on living through it, and why do you enjoy it so much?
I think if I had to be very brief here, the concept that's been most helpful for me is like this idea of like luck surface area. So, I have a lot of reasons why I started my blog, but like one of them was like I wanted to have some footprint that people could discover me through, and like maybe I'd get some opportunities through that. I got my current job because like a recruiter that Rai worked with like found my blog and thought, oh wow, this is interesting. We should try this out. So luck surface area. It's like how many people know about the things that you're doing. The more people who know about what you're doing, like the better off you're going to be. The more opportunities you're going to have. I get, multiple opportunities every week from people, wanting to work with me or start a company or they want help, like getting investment. I used to do some scouting for a venture capital firm on the side. So anything you can do to like boost your luck surface area, whether that's like publishing stuff, presenting at conferences, like networking with people and like maintaining those connections. People connect on LinkedIn and then just drop them and, you need to follow through. The more people who know about you, the easier it's going to be to find these opportunities. And like, you don't need to be an established professional to be doing this. Like, I started my blog in university, and that job with Quotamation as a founding engineer, like that was something I got through university, right? Like, I didn't need to do the industry project paper, but I took it because I figured, worst case scenario, like I get a bit of practical experience, like writing code, working on a project, and I'll probably meet someone interesting. And that could potentially turn into something down the line.
Absolutely empowering. Thank you so much for sharing all of that. Where can people find Sophia? Where can people find Brian?
Yeah, so I have a website, sophiabits.com. You can subscribe to the RSS feed or the newsletter. I'm not too opinionated, whatever you prefer. There's links to my socials at the top as well. Like, I'm on LinkedIn. I am not really into social media, to be honest. So if it takes me a while to get back, that's cool. My email's on my website as well. I look at that more regularly. And then Rye, we also have a website, rye.com. The domain was cheaper than you think it was. Nice 3-letter domain, easy to remember. Rye as in the bread.
That's amazing. And of course, all the links will be shared in the description notes below, so definitely check them out. Behind the scenes, I will ask you how much the rye.com costs. Anyways, on behalf of Perry and on behalf of everyone, thank you so much for sharing all these great stories. It was personal, it was relatable. There were so many moments behind the scenes I couldn't keep it together. But on behalf of myself, thank you so much again for being on the show.
Yeah, hey, thanks for making the time and having me on. I really enjoyed it.
Likewise. And of course, for all of you, we're going to catch you on the next one. So we'll see you later. Bye. And that was Sophia Willows, Head of Engineering at Rye. All the links are shared in the description notes below. Go check them out. If you would like to be on Podcast Room by a Software Engineer, reach out to us.
just email contact@perrytiu.com. Can't wait to have you on the show. Once again, thank you so much for listening to Podcast Room by Software Engineer. Don't forget to hit the follow button on your podcast app and leave us a review on Spotify and Apple Podcasts. It's completely free. And if you want to tell your friends about Podcast Room by Software Engineer, that's totally cool as well. Anyways, I am Perry Tiu, and I'll catch you on the next one. Big love.